All right, so today we're going to be doing lesson 31.1, which is solving quadratic equations by graphing and factoring. Really, this video is going to be an emphasis on solving quadratic equations by factoring. So I'm going to kind of skip around a little bit, but we'll be able to use, give me the pen. We'll be able to use a graph to solve a quadratic equation, and then we'll be able to use factoring to solve a quadratic equation. And then we're going to be able to describe the connection between the zeros of a quadratic function and the x-intercepts of the function's graph. So in previous lessons, we have learned that the solutions to quadratic equations, and I'm going to freehand. So solutions to quadratic equations are the zeros, which are also my x-intercepts. So when we're solving quadratic equations, we're looking for my x-intercepts, which is when y is 0. So where it crosses our x-axis. So we're going to skip around this lesson just slightly just to get the main points of it. So this is a graph of a quadratic equation. And since we have a graph of it, it is easy to find our solutions to the quadratic because they are where we cross our x-axis. There are x-intercepts. So if we look at the parabola, it looks like it crosses my x-axis at the point 0, 0 and the point 16, 0. So my solutions are when x equals 0 and x equals 16. Since we are dealing with parabolas of quadratic equations, if we may have multiple different actual situations, but most of the time we're going to have two solutions. Sometimes we may have one or we may have no real solutions. So when we're graphing it, it's pretty easy to find our solutions if there are any because it's right where it crosses our x-axis. However, we can use what we know about factoring to solve our quadratic equations as well. And this will require us to know our zero product property. So our zero product property tells us that if A or B or A times B equals 0, that means A equals 0 or B equals 0. So in order for two things to be multiplied together and equal 0, one of them have to be 0. And the factored form of a polynomial equation provides an effective way to determine the values of x that make the equation 0 using our zero product property. And remember that factored form means that we're writing our polynomial in terms of multiple things being multiplied together that would lead to our product. So, and again, I gotta keep pressing this pointer button instead of my drawing tool. So example A, it is having us factor that polynomial from the beginning problem and then setting it equal to zeros because we're looking for when y is 0. So what is x when y is 0? That's my x-intercepts. So factoring it, we can notice that we can factor out an x from both of these. So that would leave me with the factored form of x times negative 1/8 x plus 2. And then setting it equal to 0, that would help us figure out our x-intercepts. So that means if these two things multiply together to be 0, either one of them needs to be 0. So either x needs to be 0 or negative 1/8 x plus 2 needs to be 0. Well, the first one, if x equals 0, that means that x equals 0 is one of my solutions. The other one, we would still need to solve for x. So we'd subtract 2 from both sides. And then we would either divide by negative 1/8, but that's the same as multiplying by the reciprocal. So multiplying by negative 8. So then we also get the solution of x equals 16. So our solutions to that quadratic, like we saw in the graph, was x equaling 0 or x equaling 16. And we can do this for other quadratic equations. If we can get them in factored form, we can set them equal to 0 and figure out, well, what values of x do each of those factors equal 0? So starting off with just factoring, I wonder if I can get this to be a little bit smaller. I don't think so. So the first thing I'm going to do for this a is I'm going to put it into factored form. Since a is equal to 1, That means my two binomials are going to be x and x. And then I just need to figure out two things that multiply together to be c, add to be b. So negative 14 adds together to be negative 5. Well, just thinking of factors of negative 14. Negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. So these are the two numbers in my binomials. So x minus 7, x plus 2. We're almost done, but we're not quite done. We want to set this equal to 0 then to solve for when y is 0. What is x? Well, zero product property tells me that if this times this equals 0, either x minus 7 needs to be 0 or x plus 2 equals 0. Now we'll solve for x. So add 7. So either x could be 7, subtract 2, or x could equal negative 2. So my two solutions are negative 2 and 7. Okay, let's do the next one. So the next one, I'm noticing I can factor out the greatest common factor of actually 3x for both of these. So I get 3x times x minus 2. Again, setting it equal to 0 because we want to find what values of x give me a y equals 0. Zero product property tells me that if this times this equals 0, that means either 3x would need to be 0 or x minus 2 needs to be 0. Again, just solving these one-step equations, we could divide by 3. So x could be 0, could add 2, or x could equal to 2. So my two solutions are x equals 0 or x equaling 2. Last one. So again, solving this one by factoring. Oops. Nope, I can't zoom or scroll down like that. When I am solving my quadratics, I'm looking for my x values when y is 0. So that means my equation needs to be set equal to 0. And right now this is set equal to 18. So in order to solve this, we would need to subtract 18 from both sides. So we get the quadratic x squared plus 3x minus 18 is equal to 0. Now we're looking for the value of x when y is 0. So now I need to factor this. Since my a is 1, I know my binomials are x and x. So that means I'm looking for two numbers that multiply together to be negative 18, add to be 3. And I'm thinking 6 and 3, so positive 6 times negative 3 is negative 18. Add them together, we get 3. So my two binomials are x plus 6 and x minus 3. And again, that's still equal to 0. Zero product property tells me that if this times this equals 0, that means one of them needs to be equal to 0. So x plus 6 needs to be equal to 0, or x minus 3 needs to be equal to 0. Solving for x, that means x could equal negative 6, or x could equal 3. So our two solutions are x equals 3 or x equals negative 6. Again, we're going to connect this with my solutions to the 0 of, or our x-intercepts of our graph. So the graph of the function y equals x squared minus 6x plus 5 is shown below. So it says identify the x-intercepts of the graph. Well, that is going to be 1 and 5. I'm just quickly going over our vertex. Oops, wish I could just scroll. Our x-coordinate of our vertex is, remember our vertex is our axis of symmetry. It's our minimum or maximum, so the x value is 3. And we get that x-coordinate of the vertex, it is the average of our two x-intercepts, because our x-intercepts have a line of symmetry with the vertex, so they're equal. The vertex is right in the middle. So our two solutions based on the graph are 1 and 5. Now let's prove this with factored form. So it says factor the quadratic expression x squared minus 6x plus 5. So again, we have a equaling 1, so that means my quadratic is x and x. And then we need two numbers that multiply together to be 5, add together to be negative 6. Well, negative 5 times negative 1, add together to be negative 6. So that means my two binomials are x minus 5 and x minus 1. And again, that's going to equal 0. B says each of the factors we found in part A is a linear expression. Solve the related linear expression for each factor by setting it equal to 0. Really, it's using the zero product property, which tells us if one of these two multiplied, or if these two multiply together to be 0, one of them need to be 0. So that means x minus 1 needs to be 0, or x minus 5 needs to be 0. Solving both of these for x would equal 1 or 5. Again, it says solve the related equation for the expression in part A. That's exactly what we did, which is x equals 1 or x equals 5. And then it says, what do the linear factors in item 10A relate to the x-intercepts of the graph as shown below? Really it's just saying that our solutions to our zero product property are x-intercepts. So our x-intercepts are our solutions to our quadratic equations. So without graphing, how could we determine the x-intercepts? Well, we'd factor 2 set equal to 0, and then 3 solve for x. So we can solve each quadratic equation by looking at the graph or by factoring, and we actually did that throughout this lesson. We actually found our solution. So making sure we have this written out in our math notebook, which we should already have. The x-coordinates of the x-intercepts of a quadratic function of the form y equals ax squared plus bx plus c are the zeros of the function. The solution of the quadratic equation are the roots. So again, just emphasizing our solutions equal our zeros equal our roots equal our y-intercepts. And then it says, why do you think the x-coordinates of the x-intercepts are called the zeros of the function? Well, it's our x values for when y equals 0, which is why they're called the zeros. Describe the relationship between the real roots of the quadratic equation and the zeros. Well, they're equal. Our real roots are equal to the 0. Let me know if you have any questions. We'll continue to work on this in class.